All right, a good example of a negative exponent would be this. I'm just using a number here at first. What makes a negative exponent positive? Put it in the, make it a reciprocal. And so if 2 to the first goes to the bottom and that 1 becomes positive, what goes on top? How do you reciprocate something? You put it on 1, right? So this is a different way to write 1/2. Okay? So if I have 4/3 to the -1, how do I make that positive? What's the reciprocal of 4/3? 3/4. So this means find the reciprocal. All right, now what you have to remember here is that this x has what power?
1.
A 1. So x to the 5th divided by x to the 1st is x to the 4th. And then y squared divided by y to the 3rd is y to the -1. And that's what we were just talking about a few minutes ago when you asked that question about where to put the variable. Because when it ends up negative, you always put it in the numerator. But when it ends up negative, you move it. Now, you don't move the whole thing. You just move what has the negative exponent. So this x to the 4th is going to stay where it was. And this y to the 1st power has got to move because it has a negative exponent. Only the part with the negative exponent moves. Makes sense? All right, let's look at these. What property am I using right here? The what? The multiplication, the product property. And when you multiply the bases, what do you do with the exponents? So I'm going to keep the base. I'm not going to make that a 4. I'm going to keep the base. And what is -3 plus 2? -1. What did we say a while ago that would give you? Where's the 2 go? So what goes up here? A 1. That's its reciprocal. Now, when I'm using the quotient rule on this problem, that minus sign, that subtraction of the exponents is built in. I'm now subtracting a negative. I'll have 3 minus a -1. So what will it be?
Kill a negative man.
So it'd be 10 to the 4th, right? So 1, 2, 3, 4.
I forgot my homework and everything to simplify these. I left it as 10.
Oh, okay. If there's a number involved, just go ahead and simplify it.
Okay.
Alright, so this would be 7 to the what power? -2. Where does that go?
2 over
To the denominator. What is 7 squared? 49. Now what did not happen? I didn't get a -49, did I? That negative is not in the base, it's in the exponent. Not in the base, just in the exponent. Alright, this. Separate problem. 4 and 3 are not like bases. So I can't use the quotient rule, but what I can do is move that 3 squared to the numerator so that my exponent will be positive. And so 3 squared is 9, and 4 times 9 is 36. These rules make a lot of sense individually, and then when we put them together, like in those problems last night we had trouble with, we had product rule, power rule, quotient rule all together. That's what causes the problem. All right, let's try these for dollars. course, we had our negative exponent rule there also. All right, let's look at these, do them together. What rule are we using? Product. And negative 4 and positive 4 is a 0, right? Even a variable to the 0 power is 1. I mean, I could have a big problem. If I've got a 0 power, it doesn't really matter what's in here. The answer is 1. Anything to the 0 power. Okay? Numbers, variables, combination of the two, doesn't matter. Alright, let's look at this one. I'm using the quotient rule, and 4 minus 6 is a negative 2. And then 3 minus 3 is 0. This is going to be a 1. Where will this go? The d to the negative 2, where will that go to make it positive? Right, so 1 over d squared. That's it.
So that, like, where that cancels out and goes to a 1, does that say on top?
This right here? Or this one?
That right there.
This right here? Okay, what now?
Is that like,
That's like a
That
1.
stays on
Like
top, no?
times 1, yeah.
okay, good.
Alright, let's do these two. You guys are going to do these two. You know, a lot of people may see this problem differently. He saw the product rule and then did the quotient rule. Some people may see the quotient rule and subtract 6 and 4 and get a positive 2, and then do the product rule, a positive 2 and a negative 2, still give you 0. So it doesn't really matter how you go, what you do first. B to the 0 power is 1, and then this was important that you know that only the one with the negative exponent moves to the denominator. All right, let's look at these. What is to the negative 2 power?
Y.
Only y. Only y. Can a coefficient like 3 be negative? I mean, how long is it we've been dealing with negative coefficients? We haven't moved them, have we? And so only a negative exponent moves, and so it ends up like this. Only a negative exponent moves, not a negative coefficient. In the next example, if I ignore all the c's and the d's, and I just had 4 12ths, what would that reduce to? 1/3. C to the 4th divided by c to the 4th is c to the 0 power. D to the 5th divided by d to the 8th is a negative 3. Using my 0 exponent rule, this becomes a 1. Using my negative exponent power, I have to do the reciprocal of this. What's left in the numerator? 1. My 3 is already in the denominator. My d to the 3rd has to go there. We use several rules on that problem. Does anybody have a question? Alright, this problem, only the n to the negative 3 has a negative exponent. The m squared is going to stay the same, and the n to the 3rd is the only thing that has to move. You only move things with a negative exponent. I've said that over and over. Hope you guys will remember that, okay? Because that's, once you get in the mix of doing the problem, sometimes you forget those little things. Alright, you guys are going to do these two. Alright, here we go. Alright, 5/25 reduces to 1/5. 2 minus 5 is negative 3. 3 minus 2 is 1. The only thing that had to move was that a to the first. 5 was already down there. Anybody have a question? Alright, let's do the next one. Alright, y'all agree? Anybody have a question? Seems easy when you do the lesson by lesson. Alright, let's look at this. You can look at this a couple of ways. You can say, I'm going to move both of them, make them positive, and then do the quotient rule, or you can just do the quotient rule and then simplify what you need to do. So it does not matter what rule you use first. If I decided to flip them around and then use the quotient rule, I get 1 over r squared. If I decide just to use the quotient rule and say, okay, negative 5 minus a negative 3 would be a negative 2. So it doesn't really matter which rule I use first. It depends on what you see, what you notice, and that's what you'll do first. Okay? Have a question about that one? I always try to use the rule first that makes it the simplest. I'll look ahead and figure it out. If there's something inside parentheses that needs to be reduced, simplified, using the quotient rule or whatever rule, before I take it to a power on the outside, definitely do it that way first. But this problem didn't matter. Alright, here's our assignment.